All right, but we will finish the part 1 of the solving quadratics by completing the square lesson. The steps or the success criteria will make more sense once we go through the notes. But basically, if you can follow steps, then you can do this. I don't expect you to memorize the steps because I do let you use your notes on your tests. So just make sure you don't lose your notes, and that if you're not understanding the steps, that you ask questions. But I think it's pretty straightforward. And then the other thing you would need to know is how to simplify radicals, which we spent yesterday and the day before practicing. I recorded the first part of it yesterday. We're recording the rest of it now, and I'll link it in the slides. The practice, my first hour had like 25 minutes to work on, so I checked it at the end of class. So that's what I plan to do in this class today too. When it's evens or odds, that amounts to 8 questions. So I'm thinking 25 minutes is enough to do 8 questions. Make sure that you're showing your work. I have some students just providing the answers, and I don't think like they realize on your retake, if you don't solve it by completing a square or whatever method it asks for, you do get it wrong, or you don't get as far as many points as if you just followed the instructions. And there are multiple choice questions on the test that require you to know the process. Like it'll say in what line was a mistake made. And if you didn't practice how to solve by completing the square, then I guess you won't be able to answer those correctly. So you need to know each process. The exit ticket for this won't be until Tuesday because we have a whole nother note sheet to go through that is also about completing the square. So today we're just doing the part 1 of it. So questions about that? All right, so yesterday we started out with learning what perfect square trinomials are. And they're trinomials that when you factor them, you get the same exact number in this part of your diamond. So like a +4 and a +4. So it'd be x plus 4 times x plus 4. Because they're exactly the same, you can write it in this format, which is what we have to do in this lesson if we're going to be able to effectively solve for the x's. So there you go. If it's already a perfect square trinomial, you'll know because you'll start factoring it and they'll be the same exact number. I think the instructions for the practice and on the test are nice, and they tell you when it's a perfect square trinomial or not. Either way, you should be able to see if it is or not. Then it's just a matter of solving for x. And we introduced this plus or minus symbol yesterday. It's just making sure that you remember when you take the square root of a positive number, you actually have 2 possible solutions. So like square root of 25 would be +5 and -5. That's where that plus or minus covers. So then when you're solving, like -2 plus or minus 5 is -2 plus 5, which is 3, and then -2 minus 5, which is -7. So that's how you get your 2 solutions. Did we go over 2 and 4? I can't remember. Or did I just give you the answers and say we'd go over it today? Okay, so then we'll go over 4 today. So either way, here's the solutions. The notes are posted in Schoology too if someone watching this video really wants to see number 2. All right, but we'll do number 4. So number 4, the left side is a perfect square trinomial. And I know that because not only does it tell me in the instructions, hold on, my screen is still tiny. Number 4, I know the left side is a perfect square trinomial because when I set up my diamond, what number should be at the top? 9, what number at the bottom? And what 2 numbers multiply to the top that add to the bottom? 3 and 3. All right? So because I get the same number, both a positive 3, then I know it's a perfect square trinomial. I write it like this. All right, in these problems, it doesn't matter if it's set equals to 0 first. Then it's just a matter of solving for x. So like, how would I cancel a square? Good, and then whatever you do on one side of the equal sign. And square rooting something that is being squared, we'll cancel that out. That's why we did that. So that we can get the x plus 3 by itself. On the right, what's the square root of 1? Not just 1, but positive. Good. So plus or minus 1. I almost always forget that, but then I remember, oh yeah, we'll have 2 solutions, not just 1. So plus or minus 1. Then still solve for x. How do you get rid of a plus 3? You subtract 3. Do that on each side. Normally when they rewrite it, they'll put like the plus or minus number on the end, like this, but it really doesn't matter. Like you can do positive 1 minus 3, which is what? Negative 2, which is one of our answers. Or you can do negative 1 minus 3, which is good. But if they usually will write it like this in their Stratford, which is the same exact thing. Negative 3 plus 1 is negative 2. Negative 3 minus 1 is negative 4. So whatever floats your boat. Any questions? All right, now if it's not a perfect square trinomial and you're told to solve it by completing the square, then you follow this set of steps down here, which will essentially make you a perfect square trinomial. So scrolling down, first step would be to rewrite it as x squared plus bx plus c. So we want the x terms on the same side and the constant on the other side. So in this example, what would have to move? And how do you move it? Whatever you do to one side. Good. So then my left side is now x squared plus 8x equal to what's 0 minus 7. Okay. So step 1 is done. Step 2 is it's kind of a weird step, but luckily it's written in your notes and you can just follow it, is to take half of b. What number is in the b position? 8. So we're going to take half of 8, and then it says to square it. So we're going to take half of it first and square it. What's half of b or half of 8? 4. And what's 4 squared? 2. No, 16. All right, opposite of square root. So 4 squared is 16. So take half of b, square it, then we're going to add this number to both sides. That is how you are making that perfect square trinomial. And you can do that because if you do it to both sides, you're not changing like the quality of it at all. X squared plus 8x plus 16. On the right side, what's negative 7 plus 16? Good. And now we factor it, and now it's a perfect square trinomial. We actually already factored this in the warm-up if you look all the way to the top. It's the very first one we did. So like, as you set up your diamond, you see that 4 and 4 multiply to 16 and add to 8. Rolling back down. The left side becomes x plus 4 squared, because you factor it with your diamond. Right side is still 9. Questions about that? Then we did the diamond method. All right, and then last step is to basically solve for x, how we did in the first step. So opposite of squaring something is? And what you do to one side? Good. So those are all justifications. Those are all things you would put on your spider test if it asks you why did they do that. All right. You do it on the left side to cancel out a square. Do it on the right because whatever you do on one side. So x plus 4 equals to what's the square root of 9? Not just 3, but so plus or minus 3. Instead of adding 4, we will subtract 4. All right, I have -4 plus or minus 3, which we can simplify and get whole numbers from that. What's -4 plus 3? What's -4 minus 3? All right, so that's how we find our rate. Questions about that? Good. Really just can you follow steps? So if you're confused on a step, make sure you ask. All right, now to the back side, we'll do another example and then I'll give you some to try. So let's do number 7 so that we can practice the rearranging. So looking at 7. First step is to, we'll rewrite it. And the way that we rewrite it is x squared plus bx equals c. So in number 7, what would have to move to make it this format? And how do I move the 18x? Subtract it. So think, what do I have to do to make it 0? And then whatever you do to one side, do it to the other side. And does anything else have to move?
Yes.
What is it? Good. So I can't have constants with the x terms anymore for this process. How do I cancel out a positive 71? Good. Subtract it from both sides. So it cancels out on the left now. All right, clean this up a little bit. Combine like terms if you need to. Do I have any like terms on the left side? All right, no, I don't. I have an x squared term and an x term. So rewrite them in this format. On the right side, I do have some like terms to combine. What's -9 minus 71? -80. That's step 1. Questions there? All right, step 2 says to take half of b. What number is in the b position? Good, we're going to take half of it and then we are going to square it. And if you're not good at like this mental math, you can use your calculator, just like this. But what is half of -18? And when we square it, what do we get? Do you guys remember what we do with this number? Add it to both sides. That's what it says in the instruction. So take half of b, square it, add it to both sides. That gives you your perfect square trinomial on the left. We just completed the square. On the right, just combine like terms. What's -80 plus 81? +1, right? Now keep going. So factor the left side. So step 3 would be to factor. What number would go on the top? What number on the bottom? And what numbers multiply to the top that add to the bottom? Good. So then I've noticed this pattern. I mean, I don't want to kind of like go on a limb and say that it'll happen every time. I would say I know every single situation, but usually it's that number when you take half of b. It ends up going right here. All right, but then you factored it. Make sure you write it in this condensed format instead of the x minus 9 times x minus 9. Because now you can effectively solve for x. So what's the opposite of squaring something? Take the square root. Whatever you do on one side, do to the other side. So on the left, I have just x minus 9 because the square root and the square cancel. On the right, what's the square root of 1? Not just 1, but plus or minus 1. I didn't mean to write the parentheses over here. They can go away since there's nothing else. But opposite of subtracting 9 is adding 9. Good. And I wrote it kind of not the way that they would normally like me to write it, but it's okay. Still do the plus or minus. What's a positive 1 plus 9?
Positive.
Good. What's a negative 1 plus 9? Good. So those are my two roots. Questions about that? All right. I'm going to give you number 6 and 8 to try. Let's try those. We'll go over, or I'll project the solutions and explain them in about 2 or 3 minutes. All right, so 6 and 8 were the ones you were supposed to try. I'll explain them, but just so you know, for number 6, you should have had -5, positive 1. And for 8, you should have -8, positive 6. So number 6, really just follow the steps closely. First thing you want to do, I mean, if you started factoring it, you probably saw it wasn't a perfect square trinomial. So to solve it by completing the square, you needed to rewrite it into this format. X squared plus bx equals c. So that involved moving the -5. How do I cancel that out? Add 5 to both sides. That's why it equals a positive 5 now. So they rewrote it into this. So questions on the rewriting. All right, the second step says to take half of b, square it, add it to both sides. What is b in this situation? The 4. Half of 4 is what? 2, and then you square it, you get 4. So that's why they added 4 to both sides in this step, because that's what step 2 says to do. On the left, I now have a perfect square trinomial. So when I factor it, 4 on the top, 4 on the bottom, what 2 numbers complete this diamond? 2 and 2. Multiplies to 4 and adds to 4. So that's why they have x plus 2 squared over here. On the right, how did they get 9? The 5 plus 4. So from the second step, it said to add 4 to both sides, because you can do really anything to an equation as long as you do it to both sides, keep it equal. So then from there, we're solving for x. So they square root it to cancel out this square that's right here. And then they square root it over here, because whatever you do to one side, do to the other side. Square root of 9 is plus or minus 3. Good. So then opposite of adding 2 would be subtracting 2, which they did over here. They just reversed the order, which is fine. Either way, it's still -2 plus 3, which is positive 1, and -2 minus 3, which is -5. So fit there. All right, I'm going to scroll down, so I'm going to erase the little side notes. So number 8, same steps, except now it's not already equal to 0, but that doesn't matter for the completing the square. Because the first step says rewrite it to x squared plus bx equals c. So then instead of having a -50, how do we cancel that? Add 50 to both sides, and because there was a -2 already here, that's why they have a 48 there. So it's rewritten. Then we need to take half of b. What is b in this situation? Half of it would be, and then squared would be still 1. That's what you add to both sides. That's how you complete the square. Then you get a perfect square trinomial on the left. What two numbers multiply to 1 but add to 2? 1 and 1. X plus 1 squared equals 48 plus 1, which is 49. So this was a 48 here. And then you keep going. What's the square root of 49? Plus or minus 7. Over here, the square root canceled that out. And -1 plus 7 is, and -1 minus 7 is 6. All right, so now let's see what happens if we complete the square and we don't get a perfect square on the right side. So up to this point, we just happen to have perfect squares on the right side. So we're almost done. We just need to talk about these irrational solutions. All right, so when it says irrational, like irrational numbers, we're talking about basically decimals that are infinite and do not repeat. All right, like 1.3 repeating, so like 0.33333 is not irrational. Irrational numbers would be any sort of non-perfect square, because those go on forever, but then they never repeat a number. It's not just the same number over and over. Those would be irrational. So like pi, and again, any radicals. So that's what we'll do in these sets. It's just that we have to make sure the radical is simplified. That's it. We don't round the decimal or something, because that won't be exact. And to do that, let's look at number 11. So still follow the same steps. First thing you're going to want to do is rewrite it to x squared plus bx equals c. What do I have to do to make it that? Is the equation in number 11 already in that format that we're supposed to rewrite it to? So what do we have to move to make that format? I would have to subtract a 7 on each side. Good. Is that it? No, because we still have a negative x over here. So we managed to cancel out the constant on the left. We need to move this negative x. How do I move it? Add it, and whatever you do on one side, do to the other side. So now it's canceled on the right side. We're going to clean this up a bit, combine like terms if you need to. Does the x squared have a like term? The x squared doesn't. Does the 7x have a like term? Yes, this x with 7x plus x. Good. On the right, I have these two like terms with 66 minus 7, 59. All right, so now step 1 is done. Step 2, what does it say on the front of your paper? Take half of b, square it, then add it to both sides. What is b in this situation? 8. What would half of 8 be? 4. And then what's 4 squared? 16. What do I do with that 16? Add it to both sides. All right, that's what the instructions say to do, because that's how you complete the square. That's how you make a perfect square trinomial on the left side. So then the right side, we just did it so that way it keeps it equal. What's 59 plus 16? Good. Factor the left side, which we have done, I think, 3 times now on this note sheet. What does x squared plus 8x plus 16 factor to? Good, x plus 4 squared. All right, and then equal to 75. Notice now when I go to solve for x, because how do you cancel out a square? Take the square root, whatever you do to one side, do to the other side. Notice that now the right side is no longer a perfect square like it was in the previous example. So the left side, the square and the square root go away. On the right side, I have to simplify the radical. All right, if you can't simplify it, then simplify it. What 2 numbers multiply to 75? 25 and 3 is 25 prime. No, what multiplies to 25? Is 5 prime? Is 3 prime. So once you're down to your prime numbers, only look at your prime numbers, the 3 and the 5s. Because it's square root, we're looking for pairs or triples. Pairs of the same numbers. So on a pair of 5s, you write it once for each pair. Where will that go in the radical? On the outside. Any leftover numbers, prime numbers, will go in the inside. So that leftover 3. Sense? Oh, and I meant to put plus or minus over here. Let me squeeze that in. Because still there's a positive version and a negative version. Questions about that? Good so far? Now, instead of adding 4, how do we get x by itself? Subtract 4. And whatever you do on one side, do to the other side. Now, again, I don't want you rounding the radical to a decimal. So the way that you write these answers, whatever you have to do to move this number, that number will go first. And then it can just be plus or minus 5 radical 3. And that's still technically 2 solutions. It's just, we're not going to round any decimals or anything. We're just going to keep it exact with the radicals. Does that make sense? Any questions? All right, Aiden, I remember, so I'll send now. You guys try number 12, and that's really the last projected the solution. So your answer would have been 3 plus or minus 2 radical 2. All right, and then here's the explanation if you didn't get that. So first step for completing or solving by completing the square, we're going to rewrite it into x squared plus bx equals c. So what would need to move in this equation to make it that format? The 6x, how do you move it? Good. Think of what you need to do to make it 0. And then do it to both sides. Anything else that needs to move? And I move that by, good. So that's how we get this line here. Because we don't have any like terms on the left, so it's x squared minus 6x. On the right, negative 3 plus 2 becomes negative 1. So questions on the rearrangement. All right, from there, step 2 says take half of b. What's b in this situation? Half of it would be, and squared would be 9. Plus or minus, oh no, just kidding. I'm getting ahead of myself. It would equal 9. What do you do with that number? Add it to both sides. We do it to the left side so that we get a perfect square trinomial when we factor it. So 9 on top, negative 6 on the bottom, negative 3 and negative 3 multiply to 9 to add to negative 6. So we added 9 on the left to make it this factored. We did it to the right because whatever you do to one side, you have to do to the other. So -1 plus 9 is 8. Then from there, we're solving for x just like we did before. Cancel out the square by taking the square root. That's how we get the x minus 3 by itself. And notice 8 is not a perfect square, so you have to simplify the radical. What two numbers multiply to 8? And is 4 prime? That breaks into 2 and 2. So just looking at the prime numbers, do I have any pairs?
Yes.
I have a pair of 2s, any left over? Just 1, 2 left over. So the leftover goes inside the radical because it doesn't get to escape. The ones that do, you write it once for each group, and that goes outside. The question's there. And then put the plus or minus in front of it because technically anytime you square root a positive number, there's a positive and negative to it. Still need to get the x by itself. What's opposite of subtracting 3? Adding 3. And we write it like this because that's the most exact answer. I don't want you giving me decimals on these. So that's still technically 2 solutions. First would be 3 plus 2 radical 2, and the other would be 3 minus 2 radical 2. So any questions on anything? All right, so this class had a little less time to work on your practice. I don't know, I still feel like I should check it today because I don't want you to lose it over the weekend. So I'll check in with you toward the end, see how far you got. We'll decide that later. But work diligently until then. I'm fine with you listening to your own music during this time, but if you're not working, then I'll make a little note in school sheet.